My starter project is the ultrasonic parking sensor, which, as Karina already explained, it uses the ultrasonic sensors to send a signal to the buzzer. And working with this really got me interested in converting AC and DC back and forth, which I learned a lot about how that works and got to do it with this, which my main project was a bike generator that powers capacitors to store charge. And the generator actually within it, it's a purchased part, and it actually outputs AC energy. And so I had to convert that back to DC, so that was fun for me to get to use the knowledge that I had learned from my starter project. Originally, I had it all on this board, and I used this circuit, which the main component in this is this LM317 that took the higher voltage outputted from the generator and brought it down so that it didn't blow out the capacitors. But the way that the LM317 does that is that it just puts off all the excess energy as heat. So it's super inefficient. So when I finished the whole project, I then I characterized it and found that it would take probably over an hour to charge the capacitors of pedaling. So then I switched over to this piece here, which is a buck converter, which it brings the voltage down, but instead of losing the power, it increases the current, and so you keep the same amount of power from that. And I don't know where this wire is from. So with this, it's much more efficient, and so ideally I could probably charge the capacitors in about 20 to 30 minutes. So yeah, this LCD I programmed with an Arduino to display the charge level, and then it also displays a message depending on it. So right now it says I'm almost empty because it only has 1% charged. But if I it should, unless that wire is from here, it should go up. So yeah, so it's going up. It's slow, but it there eventually. Oops. Yeah, so you get the idea. And right now it's all kind of falling apart because I was actually supposed to change over to a different LCD that would have a 20 by 4 screen instead of a 16 by 9 bike computer for it. So this is called a reed switch, and this is a magnet, and so every time it attaches to the wheel, and so every time this comes by the reed switch, it closes. And so I'm working on a program that will read that it with the Arduino and be able to calculate speed based on how many times it goes around in a certain amount of time. And I've also finished a code that will tell the amount of time that you've been riding. And then with this speed, I can also calculate distance. But those codes are all use something called an interrupt, which means that, so normally an Arduino code will read through the code, but in order to have the read switch work, it needs to be able to read it whenever the magnet passes. And so an interrupt code means that the program will stop wherever it is when the read switch passes, so that it can make sure that it sees it, because otherwise it would have to either be constantly monitoring it, or it would have the potential of missing it. But because of the interrupt, you can't write like a normal computer might have like speed, and then it would overwrite that with like distance, and but because of the interrupt code, I can't do that, so I needed a bigger LCD. Some of the bigger challenges for me were, for a large portion of the time, I was working on this other stuff but I didn't have all the pieces yet, so I didn't want to redo mechanical design before I was done with figuring out what pieces I needed. So I had a lot of faulty connections and different things that I had to troubleshoot constantly. And also, coding for the interrupt has proved to be super challenging. Right now, with the read switch, I have it so that when it passes, it most of the time will light up an LED, but not always. So I used an LED because it was just getting too complicated to try and actually do anything with it. So I just said, okay, are you even seeing that there's a switch closing, which it is sometimes. So that's where I'm going from there. I just have to keep working on that code, and I got a new LCD, but the part was faulty, so I need to get a new one. Yeah, I really enjoyed this project because I finished what I had originally intended to read, and so I had a lot of time to just play around with different things that I wanted to do with it, and yeah, I really like building circuits. That's something that I learned with, I took an engineering class at my school and I loved breadboarding. And so that's really fun for me, and I've gotten a lot better at coding, which is good. It still frustrates me, but it's getting easier, so that's good. Questions? Yes.
Is there a reason why you chose to use capacitors instead of batteries?
I chose capacitors because they're easily, they have an unlimited lifespan, and they are easily recharged. And I don't know, I think that it was mostly coincidental, because I just thought of like, oh, I want to store charge. I'll store it with a capacitor because capacitors store charge. And I don't think of the battery in that way as much. So I think that it is more just kind of the first thought that came to my head. Thank you.
What's up, Taylor?